Okay, let's go over the three questions. Danny is pushing a 50-kilogram box with a rightful force of 40 newtons. If we double the amount of force, what will happen to the acceleration? So the equation that we're going to use is the force equals mass times acceleration. And we need to find acceleration from the 50-kilogram box with the force of 40 newtons. So let's plug those numbers in to see what our acceleration is. 40 divided by 50. That is equal to 0.8. So my acceleration is 0.8. So now let's double the force. So if we double the force, our force is now 80 divided by 50. There's my calculator. And you get 1.6. So our new acceleration when we double the force is 1.6. 1.6 is doubled of the original acceleration, which was 0.8. So the answer should be the acceleration will double. All right, let's look at the next problem. So we gave you the triangle here. We have a net force of 25 is applied horizontally to a 10-kilogram block. What is the acceleration? Well, since we're looking for A, if you want to use the triangle, if you cover it up, you see that we have to divide 25 divided by 10. When you do that, you should get 2.5. Okay, that is 25 divided by 10. Last problem. A water skier has a mass of 79 and accelerates at 1.4. What is the force? Well, if we cover up the F, you see that we need to multiply our mass and our acceleration. So 79 times 1.4 is equal to 110.6. Okay, so all you had to do was just multiply M times A. Okay. So the next video that you're going to see shows how to use the FMA equation when you have more than one force acting on the object. Then you will have two questions to answer, and try not to spend no more than 5 minutes on those two questions. And if you get stuck after 5 minutes for those last two questions, look at the last video to get the help.
If you're face to face with a sophisticated Newton's second law problem, you're going to need a sophisticated understanding of Newton's second law, and that's what I'm going to try to provide you with here, so that no matter what scenario you're faced with, you can apply this law in a correct way. Most people know Newton's second law as F equals ma, which is fine. It's a simple way to understand it, and it's fine for simple problems. If I had an asteroid, for instance, of mass m out in outer space, so there's no air resistance or friction, and there was only one force on it, a force F, and that force pointed to the right. Let's say that force was 50 newtons. Well, I could plug the 50 newtons into the force. I could plug the mass of the asteroid, let's just say it's 10 kilograms, into the mass, and I'd find the acceleration of the asteroid. In this case, 50 over 10 would give me 5 meters per second squared. But what if we had extra forces on this asteroid? What if there was another force that pointed to the left that was 30 newtons? So let's name these now. Let's call this F1 is 50 newtons. Let's say that's the magnitude of that force. Let's say F2 was the magnitude of the 30 newton force. It points to the left. Yes, that's the negative direction, but let's just say these forces here are just giving the magnitude of it, and then the direction is specified by the direction of the arrow. Now what would I do? Well, to handle this, we need to understand that the left-hand side here isn't just force, it's the net force, or you can call it the sum of the forces. So to denote the net force, we often write this Greek letter sigma, and sigma is a mathematical symbol that represents the sum of whatever comes after it. So this is the sum of the forces, because F comes afterward. If I had G, it'd be the sum of the G's, and if I had H, it'd be the sum of the H's. And this is a little confusing already. People hear sum of phonetically, and they think, oh, sometimes they're like, oh, so sum of, like a few of? No, we mean all of the forces. That's what this means. You add up all of the forces, that will equal the mass times the acceleration. So in this case, we'd take this 50 newtons. I could take 50 newtons because it goes to the right, and I mean, we can call leftward positive if we really wanted to, if there was a good reason, but unless otherwise specified, we're going to just choose rightward as positive and upward as positive. So this 50 has to be positive. And I can't now, by sum of, I add up the forces, but I have to add them up like vectors. This force here is a vector. Forces are vectors, and so I have to add them up as vectors. This is a vector equation. I can't just take 50 plus 30 to get the answer, because vectors that point to the left, we're going to consider negative. Vectors that point to the right, we'll consider positive. And so I'll take 50 newtons minus 30 newtons. That's what's going to be equal to the mass times the acceleration. So I could plug in 10 kilograms if I wanted to, multiply by A, and in this case I'd get 20 over 10 is 2 meters per second squared. So you have to add these up like vectors, and if I had more forces, it'd be just as easy to deal with. I can just add them up as vectors. So if I had another force here that was maybe 25 newtons, we'll call that F3. And let's say there's another force that points to the left. This one's going to be 40 newtons. So we'll have 40 newtons to the left. We'll call this one F4. Well, I can just keep including these. I can just add them up as vectors. The 40 newtons points to the left, so that's got to be a negative. I'll put negative 40 newtons. And then this 25 points to the right. I'll make that positive, so positive 25 newtons. And I can find my total force, my net force, my sum of the forces, and that would allow me to figure out the acceleration.